Now let's move on to the next topic. So our next topic is all about binomial test. What is binomial test? The binomial test is used when the experiment has two possible outcomes, for example, the success or failure, and you have an idea about what the probability of success is. A binomial test is run to see if observed test results differ from what was expected. What is binomial test used for? Binomial test uses sample data to determine if the population proportion of one level in a binary variable equals a specific claim value. So for further information, let's watch this video.
We can test the probability of success based on some experiment by performing a statistical test called a binomial test. In a binomial test, the null hypothesis is that a sample proportion comes from a population with a probability of success equal to p. The alternative hypothesis is that a sample proportion comes from a population with a probability of success not equal to p. Let's work through an example about the migration of butterflies and the impact of global climate change on that migration. In general, as climate warms, animals can either move north to cooler temperatures, or they can adapt to warming temperatures, or they can go extinct. It has been found that 24 species of European butterflies have changed their ranges. 22 of those have moved north, and 2 have moved south. Assuming these 24 species were picked at random, is the fraction of butterfly species moving north different from those moving south? Our first step, of course, is to state our null and alternative hypotheses. H0 is p equals 0.5. So we're interested if the proportion of north and south is 50%. The alternative hypothesis is that p does not equal 0.5. Note the proportion can be higher or lower than 0.5 for our alternative hypothesis. So the test is two-tailed. We know that the underlying probability based on the null hypothesis is 0.5. We also know that p hat is 22 over 24, which is the proportion of the 24 butterflies that have shifted their range north, and that equals 0.971. We also know that x equals 22, and we know that n equals 24. So first, we need to find the probability of 22 species moving northward. In this case, northward is our success. The equation would read the probability of 22 equals 24 over 22 times 0.5 raised to the 22nd power times 0.5 raised to the 24 minus 22 power, which is the power 2. We need to also calculate that 24 over 22, and that equals 24 factorial divided by 22 factorial times 24 minus 22 factorial. If we use our calculator, or we use R to calculate this out, we'll get an answer of 1.6 times 10 to the negative 5. However, we're not done. We need to also calculate the more extreme probabilities. That is, the probabilities of 23 and the probability of 24 northern movements. And I've done out the calculations here for you. We add those all together because we need to calculate the total probability and multiply by 2 to make it two-tailed. And we get p equals 3.6 times 10 to the negative 5. This is our p-value, this is our total probability, and this p-value is exceptionally low. Remember, the standard alpha is 0.05, and so if our p is less than 0.05, we reject the null hypothesis. In this case, 3.6 times 10 to the negative 5 is a lot lower than 0.5. And so we conclude that the proportion of north to south movements are not 50%. In fact, if we look at the data, it suggests that there are more butterflies moving north than there are moving south. We can also calculate confidence intervals for the binomial distribution. It's calculated a lot differently than the confidence intervals that we've talked about before, because binomial data is not normally distributed. It does not make a bell-shaped curve. So we calculate the confidence intervals by calculating this new probability, which is an accented p, and this accented p minus 1.96 times the square root of the accented p times 1 minus the accented p over n plus 4, and that is the lower limit. And the upper limit is accented p plus 1.96 times the square root of accented p times 1 minus accented p divided by n plus 4. Calculating that accented p is really simple. It's simply x plus 2 divided by n plus 4, where x is the observed number of successes.